All right, here's how I did it. I go through the first step. Miles driven is 50,000. The first miles per gallon is 10, so that's 5,000. The price per gallon is 4. 5,000 times 4 is 20,000. Now moving on to the next step, the purchase price for the first car is 15,000, plus the 20,000 from over here gets me a total cost of 35,000 over the lifetime of the car. With the second car, again we drive 50,000 miles. Now the miles per gallon is 50. 50,000 over 50 is 1,000 times 4, because we have $4 per gallon, is 4,000 for the gas cost. The purchase price was 30,000, plus the gas cost 4,000 gets me to 34,000. Now let's go on with the algorithm. Is total cost 1 less than total cost 2? No, it's not. 35,000 is bigger than 34,000. So the algorithm tells us to buy car 2. Well, what a relief. I never wanted to buy that one in the first place. But now I have a procedure that is unambiguous, executable, and terminating that tells me what car to buy. So this is a great example of an algorithm. It is a recipe of steps, each of which is so simple that a computer or a human can execute them, and it reaches an answer. Now you will notice that this algorithm here was written up in some mixture of plain English and math, not in Java code or not in any other computer language. This is called pseudocode. And pseudocode is really important when you want to develop an algorithm before you get to code it up in Java or another programming language. What most programmers do when they need to solve a complex problem is they first get out a sheet of paper and describe the problem in pseudocode, and then they write it in Java. Pseudocode doesn't have anywhere near as many rules as Java does, but still it's a good idea to restrict oneself to simple constructs in pseudocode. Let me show you what those would be.